The most basic element of any video game is interactivity, which Godot lets you facilitate in a few ways, the easiest of which being via the InputMap, a system that lets you designate any number of key presses, mouse clicks, and joystick movements to a named action. These input event actions, as they're called within the code, can then be used for easy input detection. So let's get started with how to actually set up the InputMap through the editor itself. To do so, you first need to go up to the Project tab and open the project settings. And from there, select the InputMap tab. Inside this tab, at the top, you'll see a type bar. This is where you name and add custom actions. And below that is where all the defined actions are displayed. And conveniently, Godot already comes with several UI-related actions built in, each being made up of a name, which could be changed if it was custom, analog input dead zone, and the actual inputs that are supposed to trigger the action. A single action can have several inputs assigned to it, and said inputs can take the form of either a physical key, joy button, joy axis, or mouse button. Now I do want to make a few things about these options clear, starting with a seemingly redundant distinction between physical key and regular key. What's the difference? Well, the physical key is actually a reference to the key's physical position on a standard US QWERTY keyboard, whereas key is just a reference to the key itself. To give a common practical example of what this means, let's say you've mapped out the WASD keys on the mentioned standard keyboard and someone tries to play your game using a French AZERTY keyboard. If you map WASD with physical keys, they all automatically remap to ZQSD as they are located where WASD would be according to the QWERTY standard. Whereas with the regular key binding, the keys won't remap. Obviously, this can, depending on use case, be great for making your game more accessible. So now that you know how to set up actions, let's move on to actually using them, which is generally done in one of two ways. The first being through either the input, unhandled input, or unhandled key input functions. All these functions are automatic, being called whenever an input occurs and is propagated up the scene tree to a node containing one of them, at which point they will pick up on and use the resulting input event as their only argument. The input events themselves have several functions directly relating to actions, the first and simplest of whom being isAction, which returns a bool based on if the input event matches a given action, taking a string pointing to said action as its first argument and a bool dictating if it has to be an exact match as its second argument. For clarification, when the exact match bool is false, the function will ignore any modifiers such as shift, alt, and so on for key inputs and the total movement direction for joysticks, just needing it to move in the action's corresponding direction at all, even if only barely. Also, if you're using this in conjunction with a key or button action, you'll often want to know if the action is being pressed or not, as an input event happens both on the initial press and release. For this, you can use the isPressed function, which, of course, returns a bool based on if the event is pressed or not. In addition, another thing you'll usually want to check is if the event in question is an echo. An echo being an automatically generated repeat input that keyboards make on fixed intervals for keys that are held down, which can definitely mess things up depending on what you are trying to do. So for that, you can use the isEcho function. Though all that said, if you specifically only need to check if an action was pressed or released and there's no logic that needs to be done in between, there are two functions that roll the ones just mentioned together. Those being isActionPressed and isActionReleased. Both carry over the arguments of isAction, with the latter also having an additional bool argument in between them determining if it will detect echoes. Now don't go thinking that these two functions completely obsolete isPressed when it comes to key and button events, because there will be situations where you still need to use it over them. Moving on from there, the next function to look at is getActionStrength, again using the same arguments as isAction, though this time returning a float. For most digital input, such as your typical key or button, this function will usually be redundant, as it'll always either be exactly 1 if pressed or 0 if not. However, for analog input, such as a controller's joystick, this will be far more useful, returning anywhere in the range of 1 to 0 relative to the input's strength in relation to the action's dead zone, with 0 meaning it is within the dead zone. And following that is the last action-related input event function, the ever true to its name, isActionType, which simply returns a bool representing if the input event is of a type that could be applied to an action. This is useful for making sure when a player is trying to remap their controls, they don't accidentally break things by trying to assign something incompatible, like a mouse motion. Alright, so before moving on to the second way of using the input map, I believe it's important to touch on the nuances between the briefly mentioned regular input and unhandled input functions. Starting with what it means to handle an input event, which is done through the scene tree's setInputAsHandled function, and causes the input to no longer propagate up the tree, meaning any nodes using these functions further up in the tree won't detect the input event. So if neither the regular or unhandled version of these functions can detect handled input, what's the difference between them? Well, it effectively just boils down to priority, with the unhandled input functions only being called after all of the regular input functions in the scene have finished. Typically, you'll want to use the regular variant for UI and the unhandled variant for actual gameplay stuff like controlling a character. This helps prevent the player from accidentally causing their character jump off a cliff or something while menuing by having the UI handle the input when appropriate. Also, as I'm sure is obvious, the difference between unhandled input and unhandled key input is that the former processes any kind of input while the latter only processes keyboard input. Now with all that covered, let's take a look at the capital I input singleton. This should be used over the similarly named input functions whenever you need something to happen continuously while a key is being pressed or a joystick being held in a direction. Think jumping versus walking. In the former case, you may just need that immediate bump when the input is registered, while in the latter case, you'll need to be constantly changing the player's velocity. Another common use case would to be actually use the singleton within the input function itself to check if another key is being held down at the same time another is pressed, which could be done with input's first set of 3 functions. The ever straightforward isActionPressed, isActionJustPressed, and isActionJustReleased. All of whom take a string corresponding to the action you want to check as their first argument, and a bool representing if the action must be an exact match to the current input, returning a bool. Like with some of input events functions, exact in this context means the matching input has all the given modifiers or motions required. In a similar vein, the next 2 functions, getActionStrength and getActionRawStrength, also return info on inputs, but this time for analog instead of digital. Both returning a float ranging between 0 and 1 using the exact same arguments as the previous 3 functions, with the former taking into account the action's dead zone and the latter ignoring it. Even with all those functions, it can still be a little tedious to take input events, be them joystick, WASD, or otherwise, and translate them into a value or a vector that's usable for movement. Thankfully though, the input singleton has 2 functions, getAxis and getVector, whom significantly streamline the process. The former typically being used in context where something can only move in 2 directions, taking 2 strings representing different actions as arguments, the first being the backwards direction action and the second being the forward direction action. Returning a float ranging from 1 to -1, which is equivalent to subtracting the backwards input intensity from the forwards input intensity. In contrast, the latter returns a vector and is used when something needs to move in at least 4 directions, and as such takes 4 strings as arguments, again all corresponding to actions, with the first 2 making up the x-axis and the second 2 making up the y-axis, with the order of the positive and negative actions being the same as the previous function. Okay, so all the functions mentioned so far have to do with reporting on actions that have happened, but it's also possible to simulate actions, and it's primarily done through input's ActionPress and ActionRelease functions. Both, of course, take a string corresponding to an action as the first argument, with ActionPress also taking a float that represents the input strength. 2 things to be aware of when it comes to these functions are that 1. When you use ActionPress, set action will stay in a press state until you either call ActionRelease on it or the action is triggered by a real input event. And 2, these functions do not create a fake input event, just change the state of a given action, and as such won't trigger the _input functions. Though through another one of input's functions, parseInputEvent, you can emit custom input events by just passing them in as the function's only argument. Alright, so now you know how to set up the input map in the engine's UI and how to actually use it in game. But what about modifying it at runtime? Well, this is where the input map's own functions come into play. These can be generally split into 2 groups, the ones that create, erase, and retrieve information on the input event action objects within the map itself, and the ones that do the same but for the input events inside said actions. So let's start with the first group, beginning with getActions and hasAction, the former returning a list containing all the input event action objects that are in the input map, and the latter takes a string as its only argument, returning a bool based on if there's an action with that name. Following those is addAction, which gives the input map a new action using a string for its name and a float for its dead zone. And to go with this, there is, of course, erasAction, which deletes any action with the same name as the provided string. And moving on, we have the last function in this group, loadFromGlobals. This is effectively a hard reset, erasing all the actions currently in the input map and reloading them from the defaults you set up in the actual engine's UI. Now let's look into the second group, starting with getActionList, which takes a string as its only argument and returns a list of all input events within the named action. Also, quick note, from here forward I'm going to skip mentioning the action name string for the sake of not getting too repetitive. So just assume the upcoming actions have that as their first argument unless stated otherwise, and if you're unsure, it will still be shown on screen. With that preamble out of the way, the next function, actionHasEvent, operates in a similar vein, returning a bool based on if the specified action has the input event given as the function's second argument. After that, there's the natural trio of actionAddEvent, actionEraseEvent, and actionEraseEvents, whom all do exactly what their names imply. The first two taking input event objects as their second arguments and either adding or removing said input event from the given action, while actionEraseEvents just straight up erases all the events within the action. Then there's the duo of actionGetDeadZone and actionSetDeadZone, with the former simply returning a float representing the action's dead zone, and the latter setting the action's dead zone to the float provided in its second argument. And after all that, the final function in this group and the InputMap itself is eventIsAction, which is fundamentally identical to InputEvent's own similarly named isAction function, whom we covered earlier in the video. The only difference being that it takes an input event object as its first argument. Alright, and with that we've covered pretty much everything you'll need to know about using and modifying the InputMap. Hope you learned at least a little something, and if you have any input, be it criticism, advice, ideas for future videos, or whatever else, please leave it down in the comments. Anyway, until next time, thanks for watching.